You've already learned 3 different ways to solve systems of equations. I'm not going to add a 4th here. What I want to talk about is how this relates more to Algebra 2 than it did to Algebra 1. Algebra 2 is essentially Algebra 1 but slightly harder. So we get into some more what-if type situations. Well, one of the what-if type of situations here is, on the graphing portion, what if these 2 lines don't touch in one particular spot? For instance, here's the graph of a quadratic function, x squared. Here's the graph of a linear function, y equals mx plus b. They touch in 2 spots. So if you had to solve this system of equations, you'd have 2 different answers. Or, we're not going to get this deep, but what if you have a sine function or a cosine function? They're going to touch in a lot of different spots. What we're going to get into in this class, the thing you're going to run into most often is what happens if these 2 lines don't touch at all, or what if they touch in infinitely many places? So here you have 2 equations, y equals x minus 1 and negative x plus y equals 2. You'll notice that they don't touch at all. They're parallel. So there's 0 solutions to this. Normally, the answers to both of these equations would be where the 2 lines cross. But since these 2 lines don't cross anywhere, there is no solution. Here's another example. You have 2x minus 1, and you have 2x minus y equals 1. If you graph these 2 lines, what you're going to see is they're directly over top of each other. Meaning, every point is a solution to these 2 because they touch everywhere. So in the first example, there is no solution. Whatever you think x and y is, you're wrong. And in the second example, everything is a solution. Whatever you think x and y is, you're correct. So for systems of 2 equations, you have 3 choices. There's either no solution, meaning the lines are parallel. There's infinitely many solutions, meaning the lines overlap each other completely. Or there's exactly 1 solution, meaning the 2 lines cross at one point. But graphing them isn't the problem. That's easy to see when you graph. Chances are you're going to use either the addition method or the substitution method to find your answers, but you're not going to see. So, how can you tell what the answers are or lack thereof? By using, let's say, addition method. Let me show you that. Here is a normal, straightforward problem that you would normally get, the stuff you've been used to for the last 3 sections here. Here's how you would solve it. Now notice at the end, you have 0 x's and 0 y's. Somehow, some way, when you got rid of one of the variables, the other one was also eliminated. And this doesn't matter if you use the addition method or the substitution method, this will happen. X's and y's will go away. So essentially, you're left with 0 on one side and a number on the other, in this case, 4. So, does 0 x's plus 0 y equal 4 of something else? No, it can't. Nothing plus nothing cannot equal 4. So, since nothing plus nothing does not equal 4, this is an untrue statement. It is impossible. There is no solution. No matter what you pick for x, no matter what you pick for y, you are incorrect because 0 times whatever you pick doesn't equal 4. So you're going to solve this, you're going to attempt to solve this the same exact way you would have done the last 3 sections. Just now, every once in a while, that's going to get thrown in there that both the x's and the y's will go away. You'll end up with nothing plus nothing equals something, which is impossible. So you would put no solution. Here's another one. I have a typical problem that you would normally see in the last 3 sections. Once you eliminate something, once x is gone or y is gone, what you're going to notice is, again, they're both gone. But in this particular case, the numbers are gone as well. meaning somehow, some way, when you tried to eliminate one thing, everything was eliminated. So you're left with 0x's plus 0y's equals 0. That is a true statement. Nothing plus nothing equals nothing. And no matter what I pick for x and no matter what I pick for y, that is going to be true. So every answer I can come up with is correct. There is an infinite number of solutions for this particular problem. When you end up with nothing plus nothing equals nothing, the answer is infinity. Everything's right. So, to recap, everything you've done so far, there's been one solution for. There's been an x and a y. That's considered one solution. Now, every once in a while, they're going to throw something at you with either no solution, something you cannot solve, or something with an infinite amount of solutions. You just have to be able to tell which is which. And no matter what method you use to solve these things, you should be able to see that. Just do exactly what you've been doing. Just every once in a while, you're going to come across something with either no solution or an infinite number of solutions.